from lecture 3.3. And here we're talking about a cube. So the first thing I'm going to do is draw a cube here for you, best I can. Remember, a cube has all sides are equal. Okay, so we have a cube measures n inches on each side. So this is n, and this is n, and then the height is also n. And it says if a slice 1 inch thick is cut from one of the faces of the cube. So I'm going to go ahead and cut off 1 inch from this one side here. So this is going to be all cut off. Then the distance that I have here is going to be 1 inch less. So it's going to be n minus 1. And then a slice 3 inches thick is cut from another face of the cube. So I'm going to cut another 3 inches off. Cut it off here. So that then this distance is 3 inches less. And it says the resulting solid has a volume of 1,560 cubic inches. So to find the volume of a cube, I need to multiply all my sides together. So I'm going to multiply n times n minus 3 times n minus 1, and that has to equal my volume, 1,560. So I'm going to go ahead and multiply. I'm going to perform the binomial multiplication first. So that gives me n squared minus 3n minus n plus 3, and that's equal to 1,560. I'm then going to combine like terms inside the parentheses, n squared minus 4n plus 3 equal to 1,560. Then I'm going to go ahead and distribute the n. So I end up with n to the third minus 4n squared plus 3n equal to 1,560. And then I'm going to bring the 1,560 to the other side so that I can go ahead and solve this for its zeros. So now that I've set the equation equal to 0, I can go ahead, and if I knew how to factor this, I could factor, but we don't. So we're going to go ahead and use the methods that we learned in 3.3 to go ahead and find the zeros of this function. In order to solve this, I'm going to want to look for the factors of 1,560 so that I can figure out my P over Q. First thing though I'm going to do is I'm going to apply Descartes' rule of signs, which says the number of sign variations tells me how many positive and how many negative zeros I have. So the number of sign variations in the original function is, this is a positive over here to a negative. That's one sign change. Negative to a positive, that's 2 sign changes. And then from a positive to a negative, 3 sign changes. So there's 3 variations. So that means that I'm going to have either 3 or 1 positive 0. Then I'm going to put in a negative n where I have an n, and this will tell me the number of negative zeros I have a possibility of having. So putting in a negative n wherever I have an n results in negative n to the third minus 4n squared minus 3n minus 1560. So looking at this particular function then, do I have any sign changes? No, so no variations, no sign changes. Therefore, there's no negative zeros. So when I'm doing this problem, even if I'd found negative zeros, I probably wouldn't apply to or look for them because the side of my cube cannot be negative. So that doesn't even make sense. So if we had negative zeros, I wouldn't be looking for those. So the next thing I'm going to do is look for the rational zeros. And the rational zeros are going to be the factors of 1,560. So I know plus or minus 1, and I know that plus or minus 1560. I'm sure that there's quite a few zeros. We'll do the best we can. Plus or minus 2, because I know that 2 can go into 1560, and that's 780. And then let's see, does 3 go in there? Yes. 520 times. I'm thinking that probably 4 goes in there 390 times. Pretty sure that 5 goes in there 312 times. Next I'm going to try 6. So you notice I'm just going up each integer at a time. So 6, and I'm just going to go ahead and put these down together. 260. I'm not thinking that 7 is going to go in there, but we'll check it just to be sure. No. And I'm trying 8. Yep. So we have plus or minus 8. And we have plus or minus 195. I don't think 9 goes in there, but I'll double check. No, but I know 10 does. So plus or minus 10, plus or minus 156. I'm trying 11, but I don't think 11, nope, 11 doesn't work. So next I'm trying 12. Oh, yep, 12 does work. So we have plus or minus 12 and plus or minus 130. And we need to keep on going until our factors start to repeat. So it could be a while that we're here. I'm going to say that 20 probably does. Yes, it does. 78 times 30. I'm skipping now because I'm hoping that I'm going to find a 0 before I get up this high. 30 and 52. So I've got a good smattering to start off with. I'm going to go ahead and do that and synthetically divide starting off with 1, 2, 3, 4, 5, 6, 8, 10, and so on. So I'm going to go ahead and do that. So I'm starting off with 1, and my first line of my synthetic division, 1, negative 4, 3, negative 1,560. No, that does not work. And you can see that we're very negative. Very negative. Okay, so next I'm going to try 2, and again, the first line is the same, and doing this, oh my gosh, I'm getting more negative. Not good. Okay, so then, oops, I see where I made a mistake here. This has got to be a 2. So this is going to be a positive one. That makes more sense. There we go. Negative 1558. Okay, that makes more sense. Alrighty, so that doesn't work. Next we try 3. And notice that we're only changing by about 2 places here, from negative 1560 to negative 1558. So remember that this means that P of 1 equals negative 1560. So when x is 1, this is y. When x is 2, this is y. Next I'm going to try 3, and we're back to negative 1560. So again, doesn't work. I'm going to skip up. I'm going to skip up to 10, just as I'm thinking that I'm not really getting away from this very negative. So I'm going to see if I can skip ahead and maybe find one that gets me a little bit closer to 0 than I am right now. Ah, this is getting to be a little bit better. There we go. So we're getting a little bit closer to 0. Not much, but a little bit. So the next one after 10 is 12. I'm going to go ahead and try 12 because it looks like we're going in the correct direction. When you have so many choices here, you may want to have to skip around. Getting better. What's my next one after 12? Oh, I skipped. So my question is, did I have a 15 that I should have looked at? So I'm going to look at 15 and see if 1,560 is divided by 15. And it is. So that's another 0, and it goes in 104 times. And the reason I want to pick 15 is that I'm between 10 and 12, I changed quite a bit. So I'm thinking between 12, my next one that I had listed was 20. We're going to go to the other extreme. So I'm trying to pick one that's in between. So I'm going to pick 15 and go ahead and do the synthetic division. So there has to be one between 12 and 15. So I need to find a 0 between 12 and 15. So the next 0 I'm going to try is closer to 12. 13 is divisible into 1560, and it goes in 120 times. So I'm going to try 13, and I found a 0 now. 1 0 of this function is x is equal to 13. I can now use quadratic formula because I started off with a 3rd degree. I'm now at a 2nd degree, and I can just go ahead and use the quadratic formula to find out if there are any other zeros that would work for this particular cube. Equals 0. I'm first going to see if I can factor. I'm looking at factors for 120. They're going to add up to 9, and I'm thinking of 10 and 12. That's not going to work. 2 and 60. That's not going to work. So it doesn't look like there's any factors of 120 that add up to 9. So quadratic formula, n is equal to negative b, negative 9, plus or minus the square root of b squared, which is 81, minus 4 times 1 times 120. And that's all I'll go over 2 times 1. Simplifying under the radical, negative 9 plus or minus the square root of 81 minus 480 all over 2, and equals negative 9 plus or minus the square root of 81 minus 480, which is negative 399 all over 2. So when I see this negative underneath the radical, I know that we're talking about an imaginary 0. We can't have imaginary sides of a cube, so this is not going to make any sense. We don't have to worry about any other zeros. They're imaginary. So the only 0 that actually works for this particular problem is x is equal to 13. And so the dimensions of the cube are 13 by 13 by 13 inches.